So welcome to the 5th episode in a series where I'm giving some tips and tricks on how to program using Arduino. So in this video I'm going to show you how to organize and save your device settings in your microcontroller. I think it's going to be a pretty interesting video and quite useful to most. And an update for those who are following the PCB series, the CNC upgrade parts have already arrived, so it looks like the rebuild will probably happen before the next round of experimentation, but there should be some good information in there as well as some lathe works, so I'll probably do a video for that too, so be looking for that soon. I also want to say that these programming videos continue to be pretty popular in my lineup, so it's pretty nice to sort of see that. Actually, I've been programming for nearly 40 years now. Not quite, but nearly 40 years. And I'm always continuing to learn too. So it's an ongoing process. So I think, in a way, we're sort of always all learning together here. So actually, when I started programming, the main learning tool that we had was an Amstrad regular magazine. I think it was a monthly magazine, where me and my friends would probably share the magazine most of the time. And we would copy and modify the code that they would present inside the magazine. Effectively, the magazine did for us what the internet really does for you today. Now, even though I grew up in a pretty small little country town, we were blessed with the fact that our high school actually got a special technical type designation. This ultimately meant that we actually got to have a dedicated computer class taught to us as a dedicated subject in the 7th grade, which included both history and how to do some basic programming. And even in our physics class, we had an Apple II, which was pretty much meaningless from my experience. I think we messed around with Logo or something like that. If somebody knows what Logo is, they'll know what I'm talking about. I guess it sort of makes me really wonder what all you guys out there around the world today are experiencing in your schools as far as learning computer programming. I know in Japan here the computer programming education is terrible and my kids really didn't get much help at all in high school or anything else. But I suspect that's more of a cultural artifact of Japan. I mean, it's not really a great programming society, unfortunately. And generally I'm thinking that other countries are probably doing a bit better, but, I really just don't know. Anyway, enough with my rambling. Let's get on to doing this. Now, as I covered in the last episode, I'm going to use Platform IO for this lesson, and I highly recommend that you do too. But of course, everything you see here in Platform IO is going to work in the Arduino IDE too, should you want to continue to torture yourself with that environment. I'm also going to keep this pretty much as a standalone episode and keep it super simple, so feel free to integrate it into the menu structure which I taught in earlier episodes, or alternatively you pretty much can fit it into anything else that you really want to do. I think it's pretty generic as how I'm going to present it here. First up, I wanted to talk about the settings in the microcontroller's EEPROM. In the case of the Arduino Uno, it's typically using an Atmel chip, specifically the Atmega 328P. This has a 1 kilobyte dedicated EEPROM for settings, and it has an ability to be rewritten to about 100,000 times. So this is totally separate from the program flash, and just in case you didn't know, the program flash can only be written to about 10,000 times. So you can see that Atmega have really sort of designed this EEPROM space specifically for settings being updated on a relatively frequent basis. In fact, you'll find that most of the Atmel microcontrollers that I've seen up to date anyway seem to have this split arrangement with the dedicated flash non-volatile memory and the EEPROM for settings. However, of course, you're going to find that the available space varies by the model. I know that the ATtiny 85, I believe, only had 512 bytes of EEPROM space available. Now, I don't really know what the physical difference is between the EEPROM and the flash. At a fundamental level, they're doing pretty much the same thing, but maybe they're actually making the physical structures to be able to cope with more wear and tear or something, and maybe the physical structures are bigger, and that's why they have to keep this smaller block of memory available for those settings. In any case, you might think that 10,000 or be it 100,000 writes is actually a lot. But if you do something silly like stick the settings rewrite in the main loop or in some fixed loop somewhere, then you're going to quickly burn through your microcontroller's ability to rewrite or update those settings values. So you really need to be careful how you update your settings. For my mini lathe, for example, I always provide an option to save settings only when the setting changes are actually made, and the user actually needs to consciously select the save button instead of the cancel button, so it gives them an out and makes it unlikely that unnecessary updates to that flash are going to be made. So how you manage this is really up to you. I'm not going to talk about it in this episode. I'm just going to put it out there. You just need to take care and don't do frequent updates or unnecessary updates of these settings type EEPROM. And for any of you out there who are using the STM32 blue pills or black pills or green pills or whatever they are, there's a couple of important points that you really need to know about and the things that I've experienced myself. For these devices, there are no dedicated EEPROM memory. Instead, Arduino has a driver that's been implemented that sort of emulates the separate EEPROM memory, and it actually uses the program flash. So that works pretty well, but there are a couple of downsides that you really need to be aware of. The first is that now, since you're actually using the program Flash, you don't get 100,000 settings rewrites. You only get 10,000, so it's the same as the program memory. And the second issue, which I've actually experienced myself, is that if your program gets too large, you can actually overlap into your settings space. I mean, it's pretty rare, but it can happen, and that sort of creates all sort of chaos and confusion for your program. And the third issue, which is also pretty important, is that because this is the flash memory, different to the EEPROM, actually writes in like banks or pages of memory at a time. So the EEPROM in the AppMega, you can actually individually write bytes, but I believe in the case of the STM32s, they're about 1 kilobyte or 2 kilobyte pages that have to be written all at once. And that means if you actually just use individual write commands to update the settings, then you would actually be hammering away at the same block of flash multiple times. And so not only will that slow down your code, it can also obviously vastly quicken the wear rate on your flash memory in your microcontroller as well. But even with that said, what I'm about to show you in this demonstration actually addresses some of this issue, and it's actually a little bit more advanced method and a little bit more simplified method of saving and managing your settings than actually what I did in my mini lathe. You know, when I did my mini lathe, and typically when I do any of my programming, I'm just sitting there hammering it out. I don't really try to think about too much optimization and spend too much focusing on it in any one specific topic, because there are hundreds, maybe 1,000 different topics I have to cover. So I'm just getting it done. So it's quite interesting to come back and do these lessons with you, because it actually gives me a chance to optimize or review. And so you're actually getting the better version of what I've done and the simpler versions. So in any case, let's start getting straight into some of the code and talking about how to actually do this stuff. So first up, I just want to give you a quick look at some of the normal commands that are available. I just want to give you a quick familiarization with them. We're not going to use nearly any of these, maybe 2 of these in our actual demonstration, but I just want to talk about them quickly, just so you know they're there and what they do. So I've just copied and pasted them there. The first one is this EEPROM.read, and then this space here, which is the address location, and so that allows you to read a byte at a given address location. So it's probably starting at 0 through to 1023 in the case of a Arduino Uno. Next up, we have EEPROM write address and value, and that's just writing the value at a given address. You specify the address and the value. And this update is one that I didn't actually know existed, but it obviously does a confirmation step of checking if the value has changed, and only if the value changed, it will write the byte to the memory address. Now that's obviously to reduce the amount of wear and tear on your EEPROM. To be honest, I don't really understand why they have these 2 separate commands. They should have probably just done the update, but maybe it saves a couple of cycles of process time if you just bluntly do the write. The next 2 are more interesting, and the ones that I'm typically using, and this is this EEPROM.address and then the data. Now the data can be pretty much any type of fixed size variable. So it could be a float, it could be an array, it can be a structure, it can be lots of different things. So you can stick that in here, and that's going to be critical to what I'm about to teach you. And obviously there's the get and the put, which is the save and the load of each of those. And the next 2 are other things that I've not used or not really been thinking about or have been aware about. And this one allows you to access the byte. So it's basically the same as this read. That is like a short form factor that sort of presents it like an array to access the bytes at a given address. And this last one is this EEPROM length, which just returns the size of the EEPROM. So if you were using a generic sized environment piece of code that you wanted to be transportable, I guess you could interrogate the length and make sure you're saving some sort of data set within the available actual size. But typically I don't think that's an option. You're typically going to be knowing, if it's setting something like that, you're knowing that you're going to fit within a certain type of an environment, and you're not going to use it. So I don't actually use this. And the other thing I forgot to mention is we obviously need to have at the top here, so this include is for the basic Arduino platform, so that's always going to be there, but what we need to add is this include EEPROM.h. Now I've already set up the platform ini as well, and you can see there's nothing special in here. The only thing I've got here is this monitor speed at 115200, which I like to run at the highest speed, so that's the only thing that I've added here that's different. So we don't have any includes or any library references or anything like that. It seems that this library is something generic that's available. Alright, so now you know what's available. I'm not going to harp on about that. We're just going to go straight into the mix of things. And I've already prepared a set of code, but we're just going to go through it step by step so you can understand what's going on. and I'm going to try to keep it as simple as possible, but we'll see how that goes. So if you're doing some basic settings, you could envisage a situation, I'm just going to stick it in the setup here again just for demonstration, where you want to save 3 or 4 or 5 different values. This could be data 1, data 2, data 3, and data 4, for example. And the address would obviously have to be in the right location. And that's going to work fine, but obviously you're going to have to remember what those variables are and type those in. But especially in the case of the STM32, every time you put or write the data like this to the flash memory, you're actually updating the whole bank. So especially for the STM32, this is pretty bad news, even though this is probably going to work somewhat okay, as long as you manage the address locations, etc. correctly. What I'm going to say is let's not do this. I think this is not the way to do it. I have a better way to manage these settings, and I want to show you that. And not only is it a better way, but it also solves the issue of those multiple write updates. So what we want to do is just write one block of data for all of the settings instead of writing multiple times, which is obviously going to be problematic for the STM32. So what we're going to use to make that happen is something called a structure. And yes, I know some of you out there are going to know what a structure is. But in any case, for those of you who don't, I'll make sure that we just go through it step by step. So what a structure is a concatenation of a set of variables into one structure. And that's quite useful, especially in this environment, in Platform.io environment, where you want to quickly look up something. You can just type in the name of the variable and hit dot, and it's going to give you the suggestions as to what the variables of the structure are. And it definitely makes writing the code a lot quicker in that sense. So just from a writing the code perspective, using a structure is very useful. But in this case, the other objective we're having is obviously for the STM32 type environments, where we want to minimize those hammer writing of the EEPROM, or flash memory in that case. So to make a structure, you just define it up front. Struct, there it is. And I press enter and everything came up by itself. That's pretty cool. But I don't like the way that's written, so I'm going to change that. I like that. And we're going to call it my settings. And here we put all of the variables that we want to use. So I already have a bunch of variables set up, so I'm just going to take a couple of them now for this test. So there we have it. We have a total of 5 elements in this structure, and it will have this Boolean item, which is called logic test. Obviously, it's an arbitrary name. A signed integer 16-bit called integer test. We have an unsigned 8-bit byte test, and a float value, as well as an array of 10 bytes, as you can see here as well. So here we have our structures that we can use in our settings, and let's just define quickly the object, and let's put a few labels in here while I'm doing it here. I'm going to do it nice and quickly. So that's where we can actually set up the structure, and the variable that we're going to use is a variable called settings, and it will be of the type my settings, which is a structure. Alright, so let's have a quick look at using this structure as far as how useful it is. And the first thing is obviously a Platform.io thing. So if I go settings there and I go dot, and then look, we have all of our settings items available. So this is really one of the key points that I wanted to get to you. So using this structure means you can have a fairly complex list of settings, and this provides you a quick lookup, a quick access to those settings. And obviously that's only going to work in Platform.io, which is why you should be using it if you're not using it. So we can select one there, and just like that, right? So it's pretty straightforward. Now the great thing about structures is that they also, just as with normal variables, allow you to provide actual default values. So we can put the default values or the initialization values right here, and they will be loaded in at the point that the variable gets initialized. And I'm not going to type this in, just going to copy an array just like that, and we initialize that array. So there we have it. We have our little test settings structure. We have our settings object, and we could just use that in the code. But obviously in this situation, the settings are not being saved or loaded to the EEPROM, so the settings would be lost every time you started up the microcontroller, and obviously we'd get the default values. Now before we actually get into saving and loading these values into the EEPROM, I'm going to do one little more trick, or one little more piece of advice. It's not absolutely necessary, but it's definitely a good idea, and that is to add a check value to my settings structure. And this check value is just a way to manage your versioning and to make sure that if your setting structure changes, that it will always go back to reloading the defaults, because obviously they're going to be corrupt. If you change the lineup or the content of the settings, you don't want it to be loading it from the EEPROM with the values which don't match up with the locations in the memory. It will just become a mess. So what I use is this check value as a part of the structure, and we'll put it right on the end here. So that means that if I add or remove any items from this array, once we save it into the EEPROM, the location of the check value will move and the value will obviously be incorrect. I've actually just got this value here called set check value, and you can see it's got an error. That's because I haven't defined it. And I'm going to use a definition up the top there to manage that, as opposed to hard coding a value in there. So here is my definition. I'm really not good at these C definitions. I don't fully understand them, I have to fully admit. But in any case, this is basically a text replace, as you can see here, and it's kind of put in this number wherever this text is located, as far as I understand it. Alright, let's get up to structuring this. Now actually for this demonstration, I'm not actually going to do anything in the main loop. I'm just going to use the setup to save and load the values, because I'm not going to make a menu structure or anything like that. And I definitely don't want it in the main loop, because that would be a disaster if I'm saving and loading in the main loop. I mean, obviously I could do some sequential logic or some sort of timing logic to minimize the writes, but for now we're just going to do everything in the setup, and it's going to do the same job, so I think it's not going to be a problem for you. And what we're going to do is we're going to make a bunch of tools for settings, and that's my section here. And the first thing I want to do is create a function to set up the defaults. So that's one function that I want, set defaults. So this is just the name I'm putting, it could be anything, sets underbar, set defaults. So everything I'll just call sets. And I will have another function called sets load, seems pretty obvious. And the last function we'll have is set save. Now these functions are surprisingly simple, and a lot simpler than what I was actually using in my mini lathe, just by the way that I'm doing these defaults and managing these check values. Now it's a whole lot easier and a whole lot simpler, so I won't bore you with all that, but trust me, this is pretty cool. So set defaults, obviously the idea is that we want to reset this settings value back to the original defaults value. So what we're going to do is simply make a temporary set of settings, or initialize another temporary set of settings, and then we're actually going to copy this, which is the exact same structure as this, obviously. We're going to copy this value into the data location of here. And to do that, we're going to use a memory copy function. And just to make sure you understand, this is a standard, I believe it's a very standard C function, memcopy. All you need to do is put the address of the destination data, the address of the source data, and the size of the data that you're copying. So in this case, the destination is going to be the settings variable. The source data is coming from this newly created temporary set of settings, which is going to be initialized with all the default values. And then the size of the settings is being taken from the settings variable, but it could be taken from the temp sets because they're the exact same structure, so they're going to be the same structural size. And after running that, obviously the settings value will now contain the initialized defaults. Okay, pretty straightforward. The next one that we're going to do is we're actually going to load the settings, and this is crazy simple. I'm just going to copy it in there straight for you. So we're going to load the values, and this is the command that we saw earlier, EEPROM get from address 0, because we don't need to manage addresses because it's just one big block of settings, and bang, we load the settings. So it's going to go and suck up all those settings. Now the reality is that this application may never have run before, or the settings that were there were garbage, so the settings value might be populated with garbage, and that would be pretty bad if you're running some mission critical application. So that's why I'm using this check value here to make sure. So if this value isn't exactly correct, and you can change this value over time as you upgrade these variables, whatever, or for version managing, but if this value is not matching, then you're going to know pretty quickly that this is going to be all garbage and corrupt. So that's exactly what I'm doing here, is I check that value, and I'll just paste it in there for you. It's very straightforward. Settings check value is not equal to the check value, which is from that define up there. Then go ahead and set settings to default, which is this one here, right? So it's pretty straightforward. So if this is full of garbage, then it's going to go straight away and refill it with the defaults. Easy peasy. Yeah, love it. And next up is the save, which is probably the most simplest thing of all and doesn't deserve explanation. In fact, I didn't even bother putting a comment for this, so let's have a look at it. That's it. EEPROM put address 0 and the setting structure. Oh my god, this is easy. I mean, how can you be unhappy with this explanation? It's fabulous. Fabulous. Alright, now the next thing is nothing to do with your settings or tools or anything here. It's just something I'm going to shove in here just for this demonstration, so don't be confused for it. But I just want to be able to have a mechanism to print all of those variables to the terminal so we can witness them, check them. Witness me! And I wonder if anyone gets that joke. Anyway, if we can check and see how they change as we do our little testing here. So I'm going to set up a serial port in the setup here. We don't need that anymore. The serial port will be initialized in the setup, and then I'm going to do this print all routine, and we can test that pretty much straight away, assuming I haven't made a mess of anything. And right now we have those, what have we got, right up until, where am I at? Logic, integer, byte, float. So these, and obviously nothing here worth huge amount of explanation, just printing a description and then printing the variable. And obviously if I was typing this in again, super easy because I just go settings, dot, and logic test, enter, and then bang, we get it. So nice. Beautiful. All right. What else have we got? We've got, let me check. 1, 2, 3. We've got this array, and we may as well print the check value out as well, I guess, so we can just track how that changes or is accurate. A little bit meaningless, but let's do it in any case. I'm going to stick that up the top just because it's sort of separate of the settings itself. And we want to print out those array values as well, just to see that they're being saved correctly as well. All right. So I think most of you will know this little loop structure. Finding I as an integer, 0 through 9 will be the numbers we're checking. And on each loop, I'm printing the position, 0 through 9, and I'll be printing the value of the array. All right, so that's all looking pretty good. And what I will do in the setup is where we're going to look at everything, where we're going to do all the work, is I'm just going to add these 3 little items here for the test. Sets.load, which we made up there above. I'm just going to print a bunch of lines just to clear off any garbage out of the screen, and I'm just going to print all the settings, and that's all I'm going to do right now. Let's just see if it runs, because it's going to be a waste of time if we can't get this basic section to work. Okay, there we have it. It looks pretty good, right? But these values are literally just getting the default values because we haven't saved anything to the memory yet. So what I'm going to do is, before I actually save something to the memory, I'm going to modify a couple of those values. And as we keep running the program, we should see that modification changing every time I reset the microcontroller, which I'll do here manually, and I'll just tell you I'm doing it so you can watch the result. So we need to modify the value, and then we need to save the value. We'll do that in the setup here. I know it's a little bit confusing, but I think you're going to have to just stick with me a little bit. And there you have it. So the byte value is going to be incremented by 3 plus equals 3. And the float, I'll be adding 2.2. And I'm not going to bother doing the others. I mean, this is going to be enough for what we need to see, just to see if it's actually modifying those values. So now we've modified the values here. And what I'll then go ahead and do is I will save all of those settings. And that means every time I reset the controller, we should see the value being reloaded from the memory and then effectively modified again by this amount every time. So let's just do it and stop talking about it. So there we have the values, and I'm just going to check if they've been modified already. Quite often when this boots, it actually runs it a couple of times. I'm not really sure why it does that. And it has run one time, as we can see, because this is not anymore the default value. This has actually been modified. So we know that the modification is being saved. Now, if I press the reset button on the Uno, which I'll do, 3, 2, 1. There we go, we see 133, and this float value also incrementing by that change amount that we have put here. So we can be now confident in the fact that the settings are being modified and saved and reloaded, and then obviously modified again. So this is working good. I'll just do it another 2 times. 1, 2, and there you go. So yeah, working good. So that's it. End of the lesson. Well, actually, I'm going to give you a few more tips if you want to hang around. If you've had enough, well, on your bike. If you want to see a bit more, all right, hang around, I'll give you a bit more. So what I haven't done here in this settings is the string values, and string values are not so great when working with these fixed size structures. And that's because strings are not fixed size, they're flexible length. And if I remember correctly, all of these fixed sized items all go into the stack when they're created and then are erased from the stack when they're no longer needed. But things that are variable size, such as strings, go into the heap, which is at the other end of the memory stack effectively. And they're flexible size and they create all sorts of holes and nastiness. So yeah, strings are a bit of a pain in the bum to work with, especially when we're talking about saving them to a setting. So I don't think you're going to be saving strings in a settings all that often, but I'm going to show you how to do it in a limited fashion. Now, the first thing is that we have to keep the size and form of this structure fixed, and that means we actually have to fix the length of the string, or in another way to put it is we have to limit the size or the maximum size of the string, and not actually save it as a string, but actually save it as a bunch of characters. And that's exactly what I'm going to do here. So to this structure, I'm going to add a character array called string test, and the length is going to be this definition, which I haven't added yet, called max string length. And I will define it, which we can do with a default. And the nice thing about this is that you can write it as a string, and all of those will be populated into the character array as individual characters, which is pretty cool. I mean, you could sort of write it, I believe, like this as well, with separated speech marks for each, but obviously this is a lot more cleaner. The thing about these strings in this character environment, I believe there has to be a character value 0 at the end here that has to be added to identify the end of the usable string. So when you're doing conversion from a character array to a string and back and forth, you're going to have that one extra character there. So keep it in mind, you've got one dead character. So this string length, which we will define here, I'm going to define it just as 32 because obviously we have a limited amount of EEPROM. Don't want to make it too big. That means we effectively have 31 usable characters. So whatever we write here probably shouldn't be longer than 31 characters, that's for sure. Alright, so nothing too tricky here. I think you sort of get it. Let's add the printing here to the print all so we can see it. And I'm going to put it just before the array. Doesn't really matter where I put it. Serial print the title. I'm just putting this little speech mark to sort of identify the string, and serial.print serial settings.string test. Now this serial print automatically treats this as a string even though it's a character array, and it will print until it hits that 0 character value as a string. So you don't need to do any conversion when you're using it simple like this. However, in some cases you are probably going to need to be able to convert this into a string to deal with it in a string fashion, some types of manipulation or other things like that. So I'm going to show you how to do that too, but for now this is the simple printing method, and I think that's enough for now. We're going to go and do a modification down here as well, but before we do that, let's just run it and make sure it works. Oh, there it is. Hello there, and you can see inside the, what is that called? Apostrophe? Yeah, see, my English has gone to the toilet. There you go, hello there, and that's what we've actually done. So we can now save a string. Obviously we don't know that we're saving the string because we can't modify it, but obviously if I'm resetting, it's reloading, and yeah, it's picking it up. All right. So next up, let's modify the string, and modifying a string is actually a little bit tricky because it's this character array. The first thing I'm going to do is get the value back as a string, and that's not that difficult. All you need to do is define a string and effectively push the character array into the string, just like that. So we have this variable s as a string, and we use this string type casing term that will reformat this character array into a string and stick it into s for us. All very good stuff. The next thing we're going to do is we're going to modify the string, and I've already got this again here to save a bit of time. Nothing complicated. S equals S. I'm pretty sure you probably do S plus equals, but I'm just going to leave it S equals S plus space, and I'm going to add the value of the settings byte test, this value here, just to stick something on the end there. And again, I'm typecasting it back into a string or converting it back into a string so it can be appended into that string. And there is one more thing that I'm going to do, is that every time we reset it, and let's just run it and have a look. Yeah, alright, so, oh, I haven't put it back in there. That's my mistake here. I'm not paying attention. Alright, so I've created this S, I've appended it, but I haven't put it back into the settings string test. And we have to do a reverse conversion back to get it back into our character array. There's a nice little function that's in this string object, and it's called toCharacterArray. Oh, convenient, very nice. And we're going to take the settings dot string test, and we'll do it to the s dot length, and we have to add 1. Something I found out, we have to add 1 to get that 0 character positively added to the character array, otherwise the endpoint isn't added. So we need to add 1. Oh, it's just length is a function, so got to add little, we'll add a few comments, and just a little reminder on this. Alright, let's give that a go and see how it looks. Alright, there we go, byte test 145, and we also see the hello there with the 145 appended. So now every time I reset, it should continue to append the last value onto that string until, I don't know what happens. Let's keep going and see what happens. 1, 2, 3, 4, and there you see it's gone back and it says hello there. So obviously it has corrupted the settings. This check value has become incorrect and it's reset it. So what's happened there is that we've kept appending to the string until it's gotten too large for the available size, and that's sort of corrupted the settings, and we get this result. So anyway, there's a very simple solution to this. We just need to make sure that we don't oversize the string. So whenever we're putting something into this string, we should just make sure that it doesn't exceed the size of the capacity of the string, which is, in this case, the max string length -1. So let's do that. So this is just after we append. This is not something you would practically do in your code, because you'd normally be just saving some sort of value and trimming it off or making sure it wouldn't exceed the maximum size. And I mean, one simple way to do it is that if it was too long, you could just copy a limited set of characters to the array and then just add a 0 at the last value. Anyway, doesn't matter. Let's have a quick look at what I've done here. I'm just going to make sure that if after post appending, the s.length is not greater than equal to the max length, which would be too long to fit basically. And if it is too long, I'm just going to reset the value here to be this reset value, just so we can track what's going on when we're resetting it. Okay, so what will happen is it will fill up like we did before, and instead of losing all of the settings or corrupting the settings, it will actually just set this s value or this string test value to be the reset value. So let's just do it and have a look. Not very interesting, but just so we can see it working. I mean, the key thing to say is that you just have to be careful not to, with these fixed length strings, is not to try to put a string in there which is longer than it can be accommodated by that character array. And obviously we're continuing on from the last settings save that we successfully made, and I'll just keep resetting this. 1, 2, 3, and there we see the reset. And if I press it again, the 145 from the byte test is there. So okay, so we know how to save strings and it works fine. The only thing is that if you want to manipulate the string, you're going to have to bring it back into the string world, like I've done here. Do your manipulation, make sure your manipulation doesn't exceed the maximum available characters, and then push that modified string back into that character array. It's a little bit complicated. You probably make yourself a little subroutine or something to make it a bit easier, but I just want to demonstrate how to use a string. And actually, I haven't used a string before in my settings. So there's only one more thing I want to show you, and it's just to show you how to, again, structure your settings. Should you have a really complex set of settings with a couple of different subsets, like I had in my mini lathe, which have all those different sections, it can be quite difficult to navigate if you have this huge list of settings here. So what we can actually do is we can put a structure within a structure, and so on. We can have a structure within a structure within a structure, and it's going to work exactly the same. So I'm going to do this super quick just so you can see it in use. I'm going to copy this little structure I've got prepared here. So this is just a little substructure, and we have the default set there, integer test and byte test, which is different from these obviously. And here I'll include that structure inside here. Did I get it right? Yeah, that's right, okay. So now this structure is being used in here, and we'll call it structure test. So when we initialize the object, say for example here, it's this value here. It's going to take on these two values at initialization, and all of the default operations and everything, they're all going to work exactly the same, and we can demonstrate that quickly. But to demonstrate it, we actually need to display it. So let me do that. I'm going to go partially the way there with one of them, just so you can see some of the benefits of this structure within a structure type situation. So we'll go up to there. It's the ID of the variable that we're going to look at. And again, in this platform IO, we get this nice suggestive lookup. So we press dot, and here we can see this struct underbar test, enter, and now we're into the subsection. And if we press dot, we now get the two items that are available, which makes your life very easy for managing your settings. Very nice. And I'll just copy the other one because there you go. Let's just print that out and make sure. I think I've got these values set differently. It's 26,239 is different from the values we had here. So hopefully if we run it, we're going to get that substructure value in settings. 26 and 239 just as 26,239. 26,239, yeah. So that's working well. So let's now modify these values and just make sure that we can modify them. Of course, I know that we can, but you know, seeing is believing, as they say. So let's do that. I'll just modify one of the values here alongside of those other values. Here we go. I'll stick it there. Settings.struct test.integer test minus equals 1. So we're going to reduce by 1 each time. That's it. Let's do it. $25,239, and we started off at $26,239, so it's already been reset once, and that's typical of this programming for some reason. When it programs, it resets, and then it does another reset. I don't really understand why it does that, but anyway, 2 resets when we program it. If we press the reset button now, we should see that it decreased to 24, and there we have it, 24. So structures within structures. Very, very useful and very nice. So I think that's about it for this lesson. It's probably dragged on a little bit longer than I was thinking to do, but hopefully it's got something useful in there that you can actually use in your own projects pretty quickly. I think it does. And if this video has been of some use to you, then please consider subscribing or leaving a comment or giving it a good old thumbs up, whatever it might be. Probably coming up next, I won't be doing a programming video. I'll probably be doing a CNC build video, as I said at the start of the video. But obviously a programming video will be coming up soon enough to definitely join along if that sort of stuff interests you. And I'll definitely be looking forward to seeing you then. So, see you then.